Today is May the 10th, 2019. I'm going to make a final video on this faithfully reproduced UTC W-20 Williamson amplifier. I've shown it before, but I'm completely finished with it now. Wired in an on-off switch here. Haven't decided what to do with this, but I think I'm going to do nothing with it right now. Over here, I can turn it on and off here, and I put a high voltage ready light here, which is neon. And I put a 117 NO. I got it listed as a 120, but it's actually not. I think it's a 240. It's a really long. It's a 117 NO 210 delay relay to bring the high voltage up. Give everything plenty of time to warm up. Got parallel 5U4s in it. Overkill to the max for a 20 watt amplifier. This is a massive UTC transformer. This is the primary choke that feeds power to the plates of the output tubes, and then it's got a secondary choke to feed voltage to the voltage amplifier section. This is the power amplifier section. This is the voltage amplifier section. There's two more sockets under here, octal sockets, because in building it for the lady I'm building it for, we hadn't decided whether we were going to use 7N7s or 6SN7s. They actually have the same specs. But anyway, I wired these. It's just put on there with some Velcro. It can be pulled off, and you can plug 6SN7s in there, or anything that's wired for 6 volts to pin 7 and 8 to light them up just for fun. It has a balance and a set 100 milliamps, so you can go back and forth to balance. Here's one set of tubes, and here's the other set of tubes. It's push-pull across it and parallel this way. I'll show you underneath it, and what I'm going to do today that's unique from the last time is we're going to see if there's really any difference. These KT66s are made by Tung Sol. They're beautiful. They perform just marvelously. So do these Tung Sol 5881s. They're all virtually new. They have had very few hours on them. So I'm going to consider them in the best tip-top new shape. And then what came in today that I haven't even opened yet is a set of Gold Lion KT66s. So we're going to have 3 sets of tubes that we're going to compare and see if we can really tell any difference. I think that should be fun. That should be interesting, and it's fun to document this kind of stuff. I'll open this in a minute. I'll show it to you. I have the boxes for these right here, but I couldn't find them right quick. I was going to show them to you all in their nice boxes side by side, but we'll just have to deal with it. I guess we'll test these first since they're plugged in there. I'll have to get set up and we'll start. I think first of all I'll show you underneath the chassis though, and if there's anything different than what I've done for the last time. So let's look under the chassis. Okay, here's underneath the power supply chassis. Here's that big power transformer. It's got here's the secondary, and there's the center tap. You can move these 2 wires to the inner if you want to lower the voltage a little bit. Here's a 6 volt center tap. Here's 5 volts for the parallel 5U4s. And here's the AC input. The AC input goes through this switch, and also through this connector right here that goes all the way back to that on-off gain control switch on the main amplifier. Here's where the delay relay plugs in. It's got a nice 600 volt capacitor here. These are 800 volts. I put 600 volts in there just to, well, basically I do it to warn myself, because with no load on it, that's what it floats up to. This is how I ground it. Some people, there's always lots of discussions about grounding, it seems like. I have found this to be very effective. I get no hum out of it. The hum in this amplifier, possibly one reason, because the power supply is separate, is down at minus 90 dB. You can't get much better than that at 20 watts. Now you got to remember, if you're running an amplifier at 100 watts and it's minus 90 dB, the difference between 20 and 40, well, let's say 1 watt, just so we can, I don't know if I even want to go there. But anyway, if you run an amplifier at very, very high power, then it would be reasonable to have a signal to noise ratio higher than minus 90. But for a 20, 30, 40 watt amplifier, minus 90 dB is extremely quiet. I found out that even at minus 75 dB, you don't hear any hum, even out of the most efficient speakers like the Klipschorns. Here's the old original capacitors in it. This is an original chassis. I just cut them off Left them in there to fill the holes. Here's a dropping resistor across this neon bulb. I just empirically adjust this resistor to where I get the 120 volts across the neon bulb that it wants. This is a bleeder resistor, so this thing won't sit here forever with 600 volts on it in case it isn't plugged in. If it's plugged into the amplifier and the amplifier's on and you turn it off, then you know, the load on the power supply will drain it down very, very quickly. And of course the fuse. And that's about it underneath. Let's see. Yeah, there's the umbilical cord where it plugs in, and the sockets for the 5U4. Okay, enough of that. Let's go to the amplifier. Let's take a quick look underneath the chassis. Here's where the power and control comes in from the umbilical cord. The other end being right here. Uses non-electrolytic capacitors in here for filter, as prescribed by the schematic. I use a silver-plated Teflon coated wire, which I highly recommend. This is meter lead wire. Whenever I have high voltage, I prefer meter lead wire. I use lots of lacing ties here. Helps keep it nice. Twisted wire. The way you make this twisted wire is you just put two equal lengths, pinch one end in a vise, put the other two ends in a drill, and twist them up. One of these is for balance, one of them is for setting for 100 milliamps. Here's that meter on the top. It's actually a 1 milliamp meter movement, so I had to put a shunt across it right here. They put 47 ohm resistors in the plate leads of all of these 6L6s. And 100 ohm, they strap the screen right straight back to the plate with 100 ohm resistors. Actually very simple. This is a Williamson design over here. We're using the 7N7s instead of the 6SN7s, and of course the on-off and a gain control up here. Kept the shielded wires up there, kind of keep away from the AC hum. That's really all there is to it. It's strapped for 8 ohms. Down here you can strap this for just about anything imaginable. Here's a primary input plate, and here's the center tap. I don't think there's anything terribly exciting about that. I would like to show you that wire though. I buy this wire at see if I can find it without fumbling too much. Yeah, here's what it is. So it's called a TZ18 STR. The dash 100 to 100 feet in white. It's color. If you see there, if you read it, it says 18 gauge stranded, 10 plated arrows. 10 plate. This is 10 plated. Okay, well that's not the one I was trying to show you. I have others. Actually, I think it's black. Well, this is silver plated. There it is right there. TW18 STR. Hope you can read that. 18 gauge stranded silver plated aerospace grade PTFE wire. This is good stuff. It's 41 cents a foot even in bulk. So it's not cheap. 200 feet is 80 bucks. That's an 80 buck roll of wire. It comes in red, white, and green, I believe it is. Silver plated aerospace. Yeah, really good. The insulation doesn't melt at all when you get it hot and you're soldering to it. So that's what I use. The white, the red, and the green. Okay. Here's the bottom of it. Here's something I've always liked about the other amplifier builders is this will go on the bottom, of course, when we're all through. I always like to put a schematic with the amplifier, so this fits over the bottom. We'll put on it when we do the final. And here are the gold line Genelex KT66s. Just took them out of the big box. I haven't even opened them out of here yet. So we have these, the 5881s, and the Tung Sol KT66s. I'm getting everything mixed up here. You know what these are, the 5U4s and what have you. So let's get it all set up and start making some measurements. Okay, our first set of tubes are the 5881s. It's very important to set the input voltage to something constant. I set it at 120. There it is right there. There's our input voltage. This thing's reasonably accurate to 1% or so. And our current actually only registers 100 milliamps exactly at about 115 volts input. I guess this was older technology, but it's about 105, and they're both balanced, so we're going to go with that. Okay, the first thing we're going to do right here is test it for THD at 20 watts at a kilohertz, 20 hertz, and 20 kilohertz. Okay, I've got it set up right now for 1 kilohertz. We'll crank this guy up right here to 20 watts. There we go. Just a little bit over. There you go, full 20 watts. Oh goodness, there's that glare again, isn't it? That glare. 0.06%. That's pretty darn good, isn't it? That's what it looks like. 0.06%. Let's write that down. 0.06%. Okay, now let's do it at 20 hertz. Got a lot of shadow in here too. Let's test it at 20 hertz. I don't like all this twisting I have to do here, but that's what we're going to have to do if we're going to do all these tests. Takes it a second to slow down, and there's 20 hertz. The output of our oscillator is this SG505, a wonderful little oscillator. So the output's the same, and there's what it looks like on a sine wave, and there's the distortion, 0.334, 0.333, 0.334, 0.334. Now let's do it at 20 kilohertz. Catches up pretty quickly there. There's our 19 point something a month. Let's write it all the way. Let's do the whole 20. Come on, there we go. It dropped ever so slightly. You can do that ratio if you want to. 19.85 volts. That is down a pretty insignificant amount. And that's what it looks like on the scope, nice and clean. And there's its THD 0.435. 0.435. Okay, and the last one is maximum power at 3%, clipping at a kilohertz. So let's go back to a kilohertz, or something really close to it, times 100. There's our kilohertz again. I always touch it up a little bit. There's our oscilloscope again, our power. Now let's watch this and crank it up until it starts to clip at about 3%. There we go. That's some nice symmetrical clipping, and that is at let me see, I'm gonna crank this up to 3% or something close to it. 2.8 now. There you go. There you go, 30 watts. That would still sound, I think, quite good, honestly, because there's no abrupt changes in there, and the clipping is symmetrical. So we could put that down for a very good 30 watts at 3% at 1 kilohertz. So we're at 30 watts for that. Okay, now last we're going to do a scan on it, and we'll do this for the other two sets of tubes too, but I got to set up the scan and be right back. Okay, we're set up for the scan now. There's our kilohertz, there's our power, there's our waveform, there's our THD. Then we go back over here. It takes exactly 1.58 volts to drive this thing. We say reference level okay, and we say yes. And then we watch this. It starts at 20 hertz. Holy mackerel, I can't believe that. It's got 20 hertz down here at 0. Well, it's all pretty darn low though. Look at that. That's 0.1%. I'm not making any of this up. This thing is just that good. I put the bottom back on it. I guess that maybe quietened it down a little bit. 0.1% at 20 watts. That's a little bit of an anomaly to come out with 0. I don't know why it did that. We'll straighten that line out and assume it's about 0.1. There it is out at 12 kilohertz, and next one will be 20. That's where it stops. Just under 0.5, about 0.4 something. It'll tell us right here, 0.44 kilohertz at 0.44 percent THD at 20 kilohertz. That's our reference level right there, 12.85 volts across 8 ohms. Square that divided by 8 and you'll get the 20 watts. Well, that's how it performs, ladies and gentlemen, with the 5881s. Quite impressive, if you ask me. That's the UTC Williamson. Okay, I'm going to let it cool down a little bit without changing anything. Setting the voltage back to 20 volts, driving it at 1.58 volts, all that kind of stuff. Everything's going to be the same. The only thing I might touch up would be the balance right here to make sure that the tubes are balanced. And then we'll try the next set of tubes will be these Tung Sol KT66s. Okay, now we have the KT66s in there, and here's our balance. Still looks very good. I did have to touch it just a little bit. That's a tiny bit higher than that one. I think an insignificant amount. Let's leave it as it is. I don't want to start splitting hairs here. Okay, there's our 20 watts. Always just a little bit more, so we know that we are, we're fully there. Just over 20 watts. Got some crazy glare there. Sine wave, and there's our kilohertz, and it's 0.82. So let's write that down. Wherever the pen went, I haven't a clue. 0.82. Okay, there it is. 0.082. 0.08. Actually, it's a little bit higher than the other one. A little bit higher than the 5881s. So it is. Still pretty insignificant. Okay, let's go to 20 hertz and see what it looks like. Okay, there's our 20 hertz. There's our power, still 20 watts. There's our, that's a beautiful sine wave for 20 hertz. And there's its THD 0.28, 0.286, 0.281, let's call it 0.28. 0.028. Actually, that's a little bit less. And now at 20 kilohertz, 20,000. There we go. 20,000. There's our 20 watts. Here's what she looks like. Very beautiful. And there's our THD. 0.444. 0.44. 0.44. Well, those are about the same, aren't they? 3328, 0.06, 0.08. I mean, they're all so low, it doesn't really matter. Now let's go up to what our maximum power is at 3% at a kilohertz. So we got to go back to a kilohertz. With this analog type dial, you can see that I don't always end up at exactly a kilohertz, but end up really close. Close enough. 900. There we go. 1005. Okay, there's our 20 watts. Now what we've got to watch for is a little bit of clipping, maybe. We got something loose here. Something's not quite tied down right or something. Doggone it, and I hate it when these things get to floundering around like that. Well, our power staying, it could be this, it could be, sometimes we have to fool with these, okay. When you have equipment as old as this, 35 and 40 years old, sometimes, as beautiful as it is, sometimes you have to play with the switches a little bit, because I guess they get dirty. Okay, now we're back at the 0.8% that we had a while ago. And let's crank this thing up to about 3%. Two and a half, 2.8. I don't know if we can get exactly 3. 3 a little bit more. All right, we'll leave it at that. 32 watts, and there we have our clipping. Some symmetrical clipping at 32 watts. maybe even 33, but we were right down 32. 32 watts. There it is. There's for the 2 cents. Very comparable. Now we've got to do the scan, and the good thing about the scan is we can see all of them, one right on top of the other. So I got to set that up now. Okay, sorry you didn't get to see it run there, but I don't want to start all this all over again. I've been talking to this camera while it wasn't running, but I'll repeat some of it here. The blue trace are the KT66 is made by Tung Sol. See, it started at about 1/4% THD at 20 Hertz, which makes sense. This is a little bit of an anomaly right there. I don't know what caused that. But anyway, the yellow line is the 5881s. The blue line that's going right over the top of it. You can see blue right there. The blue one that started out here. It is the trace for the Tung Sol KT66s. It goes along just right on top of the yellow line until it separates a little bit out here and does an ever slightly better job. It does about a 0.1% THD better out at 20 kilohertz. The yellow trace is about 0.45. This one's at about 0.35. To be exact, it's a 0.37 at 20 kilohertz at that power level, same as our other one. So the power level is just phenomenally flat. So that's 2 of them right there. So now all we got to do is let her cool down, and let's do the one for the gold line. Let's look at those just for a second. They say gold line, they say Genelex, and then they also say custom tube made by Electro Harmonix. Well, actually I like Electro Harmonix tubes, so I think we're going to be pleased with them. Let's see, let's get them, let's get this guy turned off. I'm going to turn it off. Let it sit there and cool for about 15 to 20 minutes. I don't like to pull out hot tubes. That's a good way to damage them. I've heard other people say the same thing, and I completely agree. Jerking them around and banging them around, especially when they're hot, is, I think, a good way to damage them. Okay, be back in a few minutes. Just a second, really. Okay, now we have these beautiful looking tubes, these gold line with all of that fancy writing on them and everything. Wow, that's got to be better, huh? They are performing pretty good. I can't get them down below about 110 milliamps per set. I do get them balanced, and the reason for that probably is because, one, they're new, absolutely new, and secondly, it is a fact that the hotter you run a tube, the better it performs. So it'll probably perform a little bit better. I haven't tested it yet. We're going to see how they perform together. But the more cathode current you have, the hotter the tube runs, the better it performs. It may not last as long, but you know what? Buy some new ones. Enjoy them. You know, run them a little hot so that they sound really good and perform really well. Okay, actually our voltage is down to 119. We won't worry about it too much. I think 119 is okay. I'll touch it to 120. Got to make everything consistent as we can. Okay, let's go to the 1 kilohertz. Okay, we're at 1 kilohertz. And let's crank this guy up to about 20 watts. Sorry for that funny glare I got there. Doing here wrong now. Oh, I probably got that turned down too low, that's why. There you go. Turn down to 20. Just a little bit over 20. Not much. Let's make sure we got a full 20. 20 and a quarter. Sine wave. Kilohertz. THD. 0.07. 0.073. 0.073%. That's at a kilohertz. We had 0.06, 0.082, and 0.73. For all practical purposes, those are the same. I would say if we measured them all over again, if we did this 2 or 3 times, we'd probably get slightly different numbers each time. Okay, let's go to 20 hertz and see what it does. Turn this thing to 20, punch that one way down there. Well, yeah, we got to turn it back down to 20 watts though. There you go, it's at 20. That is a really nice looking 20 hertz sine wave. I tell you, I've seen some pretty ugly ones at 20 hertz. It can get pretty wicked down there. Okay, and that's a little bit, that's almost 21 watts. Let's crank it down a little bit. 20 and a quarter. Okay, 0.27. We'll call that 0.27. 0.27. Well, seems like both of these are for all practical purposes the same. A little slightly better than the 5881 in that case. Let's go to our 20 kilohertz. And there's our 20 kilohertz. There's our power. Dropped ever so slightly. The decibel rating would be 10 times the log of the power ratios of 20.25 to 19.69 if you want to do that. It's a 0.445. 0.445. Very nice looking 0.445. Okay. 0.445. Well, they're all the same. 0.435, 0.44, 0.445. They're all the same. Not a bit of difference. This one did get a little bit more power. I'm going to anticipate that this one, it does 32 watts, maybe 33, maybe 34. Let's see what it does and then we'll scan it. Let's see, this is at 1 kilohertz, 3%. Okay, we go back to 1 kilohertz. Get our 1 kilohertz back. And let's see our sine wave. We're gonna drive it a little bit too hard here. Well, let's see. Let's just drive it up. I mean, look what it is now, 0.04%. Let's drive it up to about 3%. I guess we'll have to crank this one up too. There, whoops, that's a little 3.4. Let's don't cheat here. We had the others just a slight less. Okay, 2.85. Says it's 30.9. I think we can call that 31. And there it is, nice and symmetrical again. 31 watts. Actually, it's a watt less. 31 watts. Well, that's how they perform. From my measurements, the 5881s, the Tung Sol KT66, the Gold Lines KT66s, they all perform stunning, beautiful to me. But I don't see a nickel's worth of difference between them. Okay, I think I can just do this real time. We just take this off right here. We put it right up there. I think everything's set up. Yeah, that one's got to be all the way up. Yep. And then we go over here to trace 3. And click on it. And let's see how this one starts out. Oh, look there, it's purple. It started out exactly up there at 0.25. This one should have started out there too. Hope you can see it running. There it is. There it is right there. Jumps ahead. It's up to about a kilohertz now. Went past a kilohertz. Right there, right there. And let's see what it does out here at the high end. Is it going to do split the difference there? Yeah, there you go. It's actually up there a little bit closer to the 5881s. I mean, we are really splitting hairs here. It says that it's a 0.43 at 20 kilohertz. Well, that's how all 3 of them run. Again, I'll point one more time. I'll point out this is an anomaly down there. I'm sure this one should have been up there. But they're all virtually on top of each other with the ever so slightly difference beginning out here at about 10, 9, 8, 7, 6, 5. At about 5 kilohertz. They vary a little bit by as much as about 0.1%. Well, there you go. That's the mighty UTC Williamson with that LS60A transformer, massive output transformer, just absolutely massive. I mean, I don't have a gigantic hand, but look at the size of that thing. So I hope you enjoy. I know my audio fans have missed me doing many audio amplifier projects lately. I'll have a few more coming up in the future, I hope. Stay safe, and thanks for watching.